Hello students, we were discussing about periodic table. What we had discussed? We had discussed simple structure of periodic table as well as the elements of S and P block. Right now we don't need the elements of D and F block. Why? Because they are useful in class 12. Right now we are discussing about some properties of periodic table which are very useful to understand in organic chemistry. So if we want to understand inorganic chemistry well, we must have to discuss the physical as well as chemical properties of a periodic table, and that we are discussing right now. So this is very useful as well as very conceptual. So what should be the physical properties? So physical properties will be decided on the basis of either by moving down the group from top to bottom or by shifting in period from left to right. See, the vertical columns are known as groups, and since the vertical columns are known as group, we must have to go from up to down. And the horizontal column is called period, and in period we must have to shift from left to right to decide the physical properties. Okay, so which are the physical properties? Then the first one is size, atomic size. It is atomic size. Second one is ionization enthalpy. Third is electron gain enthalpy. Electron gain enthalpy. Fourth one is electronegativity. Fifth one is electropositivity. Next is metallic character. So these are the physical properties that we have to discuss throughout the chapter. These are the physical properties that we can discuss throughout the chapter. But before explaining these all physical properties one by one, first we will discuss some basic definitions. See, these definitions are conceptual definitions. They may not be present in our textbook, but it is very useful for our concept clearance. It will make us strong for the fundamental point of view. So, first is screening effect. Screening effect is the first definition which is very useful, and the second one, you know that it is inert pair effect. Inert pair effect. in screening effect, we will discuss effective nuclear charge. We will discuss effective nuclear charge, Z effective. So if you want to note it down, just note down, then we will discuss. Okay students, note it down. So let us shift towards the definitions. In which the first definition is of screening effect. The synonym of screening effect is also known as shielding effect. So either we can say it is screening effect or shielding effect. Shielding effect or screening effect can be observed in atom when the atomic number increases gradually. When the atomic number increases gradually. So whenever atomic number increases gradually, and where it increases? By moving down the group or by shifting from left to right in period. So either we shift from left to right in period or from top to bottom in group, we will observe screening effect due to increment in atomic number. Now what exactly is screening effect? So you know that atom this is simple atom, and the simple atom contains protons as well as neutrons in nucleus. It contains protons as well as neutrons. Protons as well as neutrons in nucleus. They contains electron in orbits. They have electrons in their orbits. Okay. So when we typically focus on this electron, when we particularly focus on last electron, it is called valence shell electron. Valence, it means outermost, last orbit. Last orbit is also known as valence shell. So this electron is called valence shell electron or outermost electron. Now as you all know, the electrons are negatively charged. You know that the electrons are negatively charged and the protons are positively charged. So electrons are attracted or electrons are remain attracted towards the nucleus. Electrons are remain attracted towards the nucleus due to opposite charge. But what about electron? You know that the electron and protons are of opposite charge, and that's why they have attraction towards each other. But what about the electron? You know that both have similar charge, and due to similar charge they will repel each other. So what will happen? As we are moving down the group gradually, atomic number will increase, and ultimately number of protons as well as number of electrons will increase. So whenever number of electrons are increasing, electron will repel each other. At some point, the repulsion between electron will be maximum compared to the attraction between electron and proton, and this effect is called screening effect. Okay, again explaining the same. At some point, the repulsion between electron attraction between electron will be more compared to the attraction between electron and proton. This is called screening effect. And due to screening effect, this electron will remain maximum repelled. Due to screening effect, last electron will remain maximum repelled. It will go far from nucleus. It will go away from nucleus because it is repelled electron. It is repelled electron. So this effect is called screening effect. Due to screening effect, the attraction of outermost electron. Due to screening effect, the attraction of outermost electron from the nucleus will decrease because it remains repelled. This effect is called screening effect. Okay. તો તમને સિમ્પલ લેંગ્વેજમાં સમજાવી દઉં કે ઇલેક્ટ્રોન વચ્ચે જે રિપલ્શન થાય છે એ મેક્સિમમ થઈ જાય. કોના કમ્પેરમાં? ઇલેક્ટ્રોન અને પ્રોટોન વચ્ચેના એટ્રેક્શનના કમ્પેરમાં. ધીસ ઇઝ કોલ્ડ સ્ક્રીનિંગ. Due to screening effect, electron remains away from nucleus. Due to screening effect, electron remains away from nucleus and hence it is easy to remove that electron. That is called screening effect. In screening effect, if we discuss about effective nuclear charge it means proton. Nuclear charge it means proton. As you all know, due to screening effect, this electron is remaining away from nucleus. This electron is remaining away from nucleus. So what will happen? It feel less attraction towards nucleus. It means the nuclear charge which is responsible to attract it towards the nucleus will be less. This is called effective nuclear charge. That we'll discuss later on in our 12th. Okay. Second is inert pair effect. It is also interesting. Inert pair effect. It is called IPE. So what exactly is inert pair effect? See, what is it? Inert pair effect. IPE. What exactly is IPE? Inert pair effect. So let us take an example of group number 13. Group number 13, the members are boron, aluminium, gallium, indium as well as thallium. The atomic number 5, 13, 31, 49, 81. The atomic numbers are 5, 13, 31, 49, 81. And the general electronic configuration is NS2Np1. So how much electrons are present in the valence shell? There are 2 plus 1, 3. So the general oxidation state will be plus 3, as you know that we had already discussed in our video lecture. Okay. So it is plus 3. But as we are shifting down the group, see, atomic number is gradually increasing. What does it mean? It means that the number of protons in nucleus are gradually increasing, as well as the numbers of electrons in orbitals are gradually increasing. So what will happen? The nuclear charge will increase. Atomic number increases, so the nuclear charge will increase. And as the nuclear charge increases, what will happen? The electron of this s orbital remains tightly attracted towards the nucleus. by moving down the group due to increment in atomic number or due to increment in protons, the s electrons remain tightly attracted towards the nucleus. So they will not participate in bond formation. Or here in boron they are participating because the nuclear charge is 5 only. But in helium the nuclear charge is instead of 5 is 81. So what will happen? These electrons remain attracted towards the nucleus. So they will not participate in bond formation or any of the chemical reaction. So the available electrons are only 1. It means what will happen? These both electrons of s orbital, both electrons of this s orbital become inert. Inert means non-reactive. That become inert, non-reactive due to attraction towards the nucleus. And since there are two electrons, can you say pair of electrons? Yes, we can. So this both electrons or this pair of electron became inert due to addition in a nuclear charge. And since it became inert, it will not participate in bond formation. So the electrons available for the bond formation is 1 only. So the oxidation state we can observe is +1. This is called inert pair effect. Inert pair effect can be observed in group number 13, group number 14, group number 15 and group number 16. They can be observed in group number 13, 14, 15 and 16. Group number 17 and 18, they not show inert pair effect. Due to inert pair effect, each time 2 electrons, it means one pair will become inert, and so the oxidation state will decrease by 2 units by moving down the group. See, it is already +3. By moving down the group, the stability will be +1. Okay, in 14 group the common oxidation state is +4. Now you are able to explain by moving down the group, it is reduces to +2. Or here it is +5. By moving down the group, it is +3. Or here it is plus. By moving down the group, it is +4. This is inert pair effect. The pair of s orbital remains inert. Note it down. Okay, note it down. So inert pair effect is very important. Now if they ask, okay, question number 2. If they ask what is the common oxidation state of helium? What is the common oxidation state of helium? It is +3. But what is the stable oxidation state of helium? It is +1. See, the common oxidation state of every element of group remains same. For this group number 13, the common oxidation state is +3 only, and it remains same throughout the group. But the stable oxidation state may be varied. What should be the stable oxidation state for helium? It is +1. So this is what we can say inert pair effect. It is very important to decide some properties like electronegativity, reduction potential. So many properties can be decided on the basis of inert pair effect.